Hi, my name is Akshita. I and my teammates are going to give a short presentation on semi-supervised learning topic. So semi-supervised learning. So semi-supervised machine learning is a combination of supervised and unsupervised machine learning methods. So basically with more common supervised machine learning methods, you train a machine learning algorithm on a labeled data set in which each record includes the outcome information. So, in contrast, unsupervised machine learning algorithms learn from a data set without the outcome variable. So, in semi supervised learning, an algorithm learns from a data set that includes both labeled and as well as unlabeled data. Mostly unlabeled are used. So, these algorithms utilize small amounts of labeled data and large amounts of unlabeled data for classification tasks. So, why is semi supervised learning important? So when you don't have enough labeled data to produce an accurate model, and you don't have the ability or resources to get more data, you can use semi supervised techniques to increase the size of your training data. For example, imagine you are developing a model intended to detect fraud for a large bank. Then some some fraud about is noticed, but other instances of fraud are slipping by without your knowledge. So you can label the data set with the fraud instances you are aware of, but the rest of your data will remain unlabeled. So using the semi-supervised learning algorithm to label the data and retain the model with the newly labeled data set. So then you apply the retrained model to new data, then more accurately identifying fraud using supervised machine learning techniques. So as you can see here, there are different sections in semi-supervised learning, which are label spreading, label propagation, and label training. So let us discuss what is label spreading. So label spreading minimizes a loss function that has regularization properties and is often more robust to noise. And the algorithm iterates on a modified version of the original graph and normalizes the edge weights by computing the normalized graph, like a Laplacian matrix. So, and this is the label spreading command which we use in semi-supervised learning. So class sklearn semi-supervised learning label spreading kernel is equals to RBF, gamma is equals 20, n neighbors equals 7, and these. So here kernel, gamma, n neighbors, alpha, maxiter, these all are the parameters which are used in this command. So kernel, uh, so string identifier for kernel function to use is only RBF and KNN strings, and gamma is float type and its default value is 20. It is a parameter for RBF kernel. Next is neighbor. Neighbor is int type and its default value is 7. And it is a parameter for Canon kernel, which is a strictly positive integer. And next is alpha. Alpha is float type and its default value is 0.2. It is a clamping factor. Like if alpha is equals to 0 means keeping the initial label information, but if alpha is equals to 1 means replacing all initial information. And next is maxiter. Maxiter is a n type and its default value is equals to 30. It specifies how many maximum number of iterations are allowed. Next is tolerance. So it is a convergence tolerance, which means threshold to consider the systems at a steady state. Next is njobs is a int type and its default value is none. So there are different types of methods in label spreading. So fit X and Y. So it fits a semi-supervised label propagation model to X. And next is get param of deep. So it gets parameters for this estimator. So the parameters here are deep, which is a Boolean type, and the default is equal to true. Next is predict of X. So it performs inductive inference across the model. So here the parameters are X, which is a data matrix, and it returns predictions for input data. Next is predict probability of X. So it predicts probability for each possible outcome. So the parameter here is X array, which is a data matrix, and it returns a normalized probability distributions across the class labels. And next is a score of X, Y samples of weight. So It returns the mean accuracy on the given test data and labels. So here the parameters are X array, which is test samples, and next is Y array, which is true labels for X, and the last one is sample weight, where it is where its default is equals to none. Next is set params of params. So it sets the parameters for this estimator. So here the parameters are params, which is a dict type, and it has a estimator parameter. So this is all about label spreading. So the next topics will be explained by my teammates. So thank you.
Hello, this is Subbu and I'm going to discuss about label propagation. So, why do we need labeled data? For deep and complex neural networks, we require a tremendous amount of labeled data for high performance. Generally, creating a large dataset is a huge effort. It needs human effort to manually label the data, financial expenses for hiring labelers and for infrastructure, and it is also a huge risk and pain. So to overcome this, we have label propagation algorithm. So what is label propagation algorithm? So it is based on the manifold assumptions to make predictions on the entire dataset and use these predictions to generate pseudo labels for the labeled data. At the core, the transactive method lies in nearest neighbor graph, so it iterates between these two steps. So how does label propagation works? So here in the example, the triangle denote labeled data and circle denotes unlabeled training data. So the propagation method is employed, and based on the predictions and pseudo labels, it labels the unlabeled data. So here all the nodes have soft labels assigned based on the distribution over labels, and then labels are propagated to all the nodes through edges, and each node will update its label iteratively based on the maximum number of nodes to its neighborhood. And this process stops when each node of the unlabeled data has been majority label of its neighborhood. So once the process is done, all the unlabeled data will have the labels. Iterative process with label propagation. So step 1, starting from the randomly initialized network with the labeled data, then a iterative process is initiated where at each iteration a nearest neighbor graph of the training data in the future space of the current network is computed and labeled. So it will start the iterative process, and in each iterative process a neighboring graph of the training set in the future space of the current network is computed and labeled. So by the end of the process, all the unlabeled data will be labeled. So then the network is trained on the entire training set with the true labels or pseudo labels on the labeled or unlabeled examples respectively.
Hello, I'm Shweta. I'll be discussing about self-training. When it comes to machine learning classification tasks, the more data is available is the better. In supervised learning, the data must be labeled. If not, the algorithm may not be able to learn the relations between the independent and the target variables. But for building the large labeled dataset, it can be time consuming and also expensive. Here, in semi-supervised approach, we can train classifier with small amount of labeled data and use the classifier to make predictions on unlabeled data. That is, these predictions are better than the random guessing. So here are the steps for self-training algorithm. That is, first we will split the data into two instances, that is trained dataset and the test dataset. Then we will train a classification algorithm on labeled data, training dataset. We will let the trained classifier to predict class labels for all the unlabeled data instances. Out of all the predicted labels, the ones with highest probability are adopted as pseudo labels. Then we will concatenate both the label training dataset and the pseudo label data and retrain these classifier with the combined data. We'll be using the trained classifier to predict class labels for the label dataset instances. Then we will evaluate the classifier's performance. We can repeat step 1 to 4 until there are no predictions available from step 2. So till now whatever I have explained is in the like normal terms. That is labeling training data set as shown in this figure. Sorry, as in this figure, and then generating the pseudo labels with the classified predictions, and then combining both and retraining them, and also making the test predictions on the test label data. But coming to the technical terms, here is the self-training classifier, which is being called with any classifier that implements prediction probability, which is being passed as a parameter-based classifier. This basic classifier predicts the labels for the unlabeled samples and adds a subset of these labels to labeled dataset. Choice of subset is determined by selection criteria. Out of all the predicted probabilities, k-base samples are chosen. Then these labels used for the final fit as well as the iteration in which each sample was labeled are available as attributes. The optional maximum iteration parameter specifies how many times the loop is being executed at the most. If we set maximum iteration to none, algorithm will iterate until all the samples have labels or no new samples are selected in that iteration. Here is a simple code which we got. We have used from the scikit-learning, and we have seen how exactly it behaves during the self-training. And I got this from the reference, and this is how the plot shows. And as you can see, this plot contains all the amount iterations, and also the accuracy, and also the amount of label samples that are being increased based on the iterations. And at some point, it's became null, which says all the pseudo labels have been labeled properly after like good number of iterations. So that is it. And I have also placed a reference for the code. And so these are the questions. The first question for this presentation is, which method will return the mean accuracy on the given test data and the labels in label spreading? A, fit X and Y. B, predict proba X. C, predict X. And D, score X and Y with sample weight. The second question is, which process is used for label propagation algorithm? A, reversible process. B, incremental process. C, iterative process. D, decremental process. Question number 3. What predicts labels for the unlabeled samples and adds a set of these labels to the labeled dataset? A, base classifier. B, threshold. C, predict. D, maximum iterations. Thank you.